The slides are going to be made available after the talk, and you can just follow this link in case you want to revise the content later. And I just want to start with a question. What comes to your mind with the word Jupyter? If someone says Jupyter, what is the first thing that springs to your mind? Anyone? Flooded. Oh, the planet. Yeah. Okay, that's a good one, but that's Jupyter with I. Another? No? So I imagine that for a lot of you, this is the image or this is a picture that comes to your mind when I say the word Jupyter. But in reality, the whole Jupyter as it is much, much broader. It is a community of people all over around the world that are users, maintainers, contributors, or people advocating for the use of the Jupyter ecosystem. Because Jupyter is more than just the notebooks. It is a set of open tools and open infrastructure. And one of their main characteristics is that they're completely language agnostic and they're modular. Although we in the Python community use the Jupyter notebooks a lot, they were born from the intersection of Julia, Python, and R, and then with a view of it being completely open. And in terms of community and social aspects, it's also a means to empower people to do more. With the surgence of Jupyter notebooks and the whole Jupyter ecosystem, we've seen a lot of data scientists, researchers, communicators, journalists doing more and more with their data, doing more with their tools, thanks to the notebooks and a lot of tools. So this is, again, the most familiar example, and this is what I'm going to be talking mostly about, and it's the Jupyter notebook, or the notebook as a protocol. So when we go and open our Jupyter notebook or our Jupyter lab or whatever that we're using to interact with this, what is actually in there? And it all starts with you, and then your need to interact with the package ecosystem. More than likely, this is the SciPy, or the PyData, or the R ecosystem, or the Julia ecosystem, or whichever tools that you want to interact with. And then the whole abstraction that we see as the code interlinked with the comments and then the plots and everything is all bundled together in the document specification. And that's this JSON object that contains, is self-contained. It has your metadata, it has information of your code, it has your outputs, and everything that you've been working on. But for you to be able to interact with this document specification, we have a server protocol and a kernel. And this is basically what matches this specification with the ability of you to do compute. If my memory is all right, I think there are around 80 kernels, and you have both static and dynamic programming languages. So that means that you can easily use Python or things like Fortran or C or Scala through your notebooks. And then the actual thing that you interact with, the actual UI, is your notebook interface. And because they're so popular, there are many, many flavors and many variants. Probably one of the most popular, as they say, is Jupyter Lab. That is the native one developed by the Jupyter core team. But there are others like Interact, for example, that aims to bring this whole abstraction of the notebooks to your desktop. And of course, we also have Azure Notebooks, that is the notebooks on the cloud, and this is something that Microsoft works in. But they all follow the same pattern. They all have the same notebook document specification, a kernel, a server, and this facing interface that allows you to interact with all of this. So why are notebooks so popular? Everybody, or most of the people in this room, I imagine, are interested in notebooks or have used them in one way or another. And why is this? To start with, it's very, very easy to start iterating. As soon as you start writing code, you can evaluate it in real time, see the outputs, get your plots, and get started very, very easily. And it also matches very perfectly with this literate programming paradigm, where your code is embedded within a whole document that is more human readable rather than just computer readable. So one of its niche for the notebooks is in prototyping and dissemination. But also, we can have many, many flavors. We can start from that very static document specification that is a JSON object and transform it into something more dynamic. If you're doing a presentation, you can spin out your presentation from there. You can have your statically served documents. If you go, for example, to GitLab or GitHub, and you have stored your documents there, or in MVB, or you can see them there. And we also have some more interactive ways to work with Jupyter. Some things like Binder, Binder Hub. And we can also have longer formats of the notebooks. For example, you can have 10 or 20 or as many notebooks as you want, and then compile them all together into a book. Whether it's a printed book that you can normally edit through LaTeX and use tiny text, or something of the such, or an ebook. And hopefully, my demos are going to work. So just to demo this is a normal Jupyter notebook. It has code, explanations. And if we use the appropriate tools, in this case, I'm using Rise from Tania Allard, you can transform this straight away into Reveal.js presentations. And they're not only static, but as soon as you get, for example, to cell, you can evaluate your cells. So let me see if it works. Oh. So you can evaluate your cells in real time. You can evaluate your Jupyter notebook. So you can not interrupt your workflow. And as soon as you have, for example, this on Jupyter notebook, you can see the metadata. And this way is how you actually split your content into slides. Then if you want something more interactive, let's say that you are putting together a demo or a prototype or a report as a data scientist, and you want to share this with someone in your executive team or someone in sales or someone in upper management, and you don't want them to install Jupyter notebooks and all of your content dependencies or all of your R dependencies, you can spin out something called Binder. And these are basically containerized environments, and they give you everything you need to start working directly with Jupyter notebooks without the need to install. So you only have a URL, you can send that URL to someone, and they can straight away go and play and interact with the notebooks. And this is very, very powerful, because we no longer rely on people having to install things from scratch. So it's taking a bit longer, as usual. And it's very nice, it's very interactive. So you can see from the start the static version of the notebook. And all of this is in the cloud. All of this is somewhere in the cloud, and then as you're building this, or as you're doing this, the Docker container is being pulled or is being created, depending if it's the first time that you're binderizing this. This is taking a very long time. Okay. Let me get to this. And I have other examples. You can also create notebooks. One of the things that I said is you can create, books from notebooks. And you can also have static books or interactive books. And again, all of these is based either on Binder Hub or on TableLab. So this is a notebook transformed into book, and you can interact with this. So you can run your cell, and in real time, it should evaluate, or you can restart your kernel, you can run all the things that are here. You can have other versions like this, where you're also, where again, it's all based in binary, and you can evaluate your code. So again, it's creating, pulling your Docker container and evaluating everything in real time. Oh, cool. So this is the example of Binder. I didn't install anything, and I can run everything as if I had a local install of all the dependencies and the Jupyter notebook in my computer. And this is very, very powerful, because that means that you start with a single specification, and you can have many, many flavors depending on who you're sharing your content with, what you're generating your content for, and you can reuse without having to replicate efforts. And all of this is possible thanks to another tool that the Jupyter team put together, and it's called MBConvert. So under the hood, it does all the conversion from JSON to HTML or Markdown or whatever format you need. And also, we understand that data scientists sometimes they want to spend a lot of time building containers or tuning down containers. So there's this very nifty package that is used under the hood for Binder Hub. And if you have a repository with your notebooks, you have a requirements.txt file or an environment.yaml, you can even have a Docker file. It will create your readily usable container for you. So it removes that layer of complexity of building containers from scratch. And you can have even more interactive things now with your notebooks. You can use things like IPy widgets. So now you can create completely reactive plots and things of the such. And for those of you that were very jealous of Shiny apps, I was very jealous because I dab a lot into Julia, our Python communities, and our community for a very long time has had these Shiny apps that are amazing dashboards, and we've been missing things like this in the Jupyter community or in the Python community. We now have a couple of libraries, for example, that allows us to create dashboards, and one of these is called Panel, and is created by Conda. And you can you can straight away create your dashboards inside your notebooks. You can have, again, completely interactive dashboards. This is another example. Oh, it died. And another example of this is Voila, where you have your notebook. It has a CLI application, and then you can interact very dynamically. So from having widgets, you can create a full dashboard. And this is very, very powerful because sometimes you, when you're taking your insights to your upper management or to other parts of your team, they like seeing all of these shiny dashboards, or they just want to interact with data and play with the plots in certain ways. And this gives us many, many possibilities as a data scientist or someone working in scientific computing. And something that I was very excited about when it was announced is the native support for async from IPython 7.0. Now you can use async IO natively. So this is both on the REPL and the notebooks. And all of this is amazing. I've only talked about very amazing notebooks, very amazing tools, but as everything in life, nothing is perfect. I spoke about a very, very vast ecosystem, a very big community, and a lot of users all over the world. But it's so vast that it's very, very hard to keep up to date with what's going on next. And then people are trying to use these modular tools or these modular components in very different ways, or sometimes you're reinventing the wheel or duplicating efforts. So I find it, even I, that I'm very into the Jupyter community, I find it very, very hard to keep up with that. And also, there is a lot of resistance. Joel Grus is an amazing folk, and he just created a lot of polemic around him not liking notebooks, because there are a lot of anti-patterns and a lot of things that actually aren't very good practices when you're using notebooks. For example, there are a lot of hidden states and non-intuitive workflows. When you're using the REPL, for example, as you're evaluating, it follows the order, and then there is no way that you can go back and rerun something that you ran before without noticing. So if you're experienced, probably more than likely you've encountered something like that, you run your results or you go back, and then it turns out that that function that is x plus 2, then when you do the function of 2, it should give 4, right? But then when you evaluate the output of that cell, it gives you false. And why is that? It's because probably in the middle, in between, you did something else. You run again another cell that conflicts with what you're expecting. So if you're not an experienced user all of this is very obscured and is very abstract to you. And then again, notebooks are so popular that everybody has now their way to interact with them. Azure Notebooks, Colab, Interact, Jupyter Lab, Stencil, all of these flavors. But as we start growing all of these ways to interact, also the complexity of the interaction increases, and they become counterintuitive. And this is a nice tip that I found, like, oh yeah, Colab is fine, until you understand that you have to do all of these things to get it working, which is not intuitive at all. And also, this is one of my pain points, I spend so much time reviewing code. A very great deal of my job is reviewing code. So people will send a pull request, and I will have to review the code. And if you have ever tried to do a diff of a notebook in GitHub, this is what it looks like. And it's beautiful, right? It makes absolute sense. I know completely what is going on there, of course. It doesn't. It's not intuitive. So again, this means that I have to change my workflow. The workflow that I've been working with for years to review code in different environments is no longer applicable. And that's a pain. But then also people get so attached to notebooks that they start doing very weird things with notebooks, like present your data science results in the right way, how to import one notebook into another. Why do we want to do that? And this is because we're trying to cross the boundaries of what notebooks or what a certain tool was designed for. There is also this Stack Overflow questions on how to create modules in Jupyter Notebook and import them. This points to a flawed logic or a flawed software engineering practice. Why would you decide to create modules inside a notebook and then import them? Then it makes much more sense to move to a more traditional approach of having your modules into Python scripts and use them as you import, for example, pandas or NumPy. But this happens because, one, Jupyter Notebooks are very familiar, and two, they're used by a lot of people that have no proper software engineering training. And that's fine, because one of the purposes of the notebooks is to empower all of these folks that are not software engineers by training to do more. And something else that I hear a lot is, okay, so notebooks don't scale. Notebooks are not for production, so they're just toy things. Yes, it depends how you're asking this. And it depends how people are using all of this. Even Jake Vanderplatz, that is a massive user of Jupyter Notebooks, well, one of the problems is that notebooks encourage a lot of flawed practices, so they're not reproducible, and people should always register the execution order. Also, cells should not be added, and all of that. So it is all because of different practices, or practices that we normally have in software engineering that we've not taken back into data science or into our usage or workflow with notebooks. So how do we deal with this? How do we tame these beasts that are Jupyter Notebooks? So the first part of my talk was about the community and highlighting that the Jupyter ecosystem is in fact a set of building blocks and how amazing they are and how many cool things you can do with them. So the real truth to tame the beast and have coherent workflows and coherent usage of the Jupyter Notebooks is trying to find a way to make your life easier. To start with, avoid the urge to reinvent the wheel. Sometimes when we're using the notebooks, and I've been guilty of this, or when I'm using the Jupyter Lab, I go and say, like, oh, it would be amazing if there was this extension. It would be amazing if I could do this, and then I go and hack and do hacky bits to suit my workflow. But probably it's just my very personal workflow, and somebody else somewhere probably has a better solution that is more applicable to a wider range of cases. And I could, one, either use the solution, contribute to the solution, and get people to adopt that solution. After all, everything in the Jupyter ecosystem are building blocks. They're like Lego blocks that you can stack together. Binder Hub, for example, is using the abstraction of the notebooks. It's using repo to Docker under the hood, and we convert Kubernetes and the cloud, and it puts it all together. So we have all of these building blocks. We have to get creative about how we're using them. The second is enforcing good practices. And this sometimes takes a lot of effort because it also means that because notebooks are not designed for traditional software engineering tools, we have to use yet more tools to enforce these practices. And the tool that I love when I have to share notebooks with others, either my colleagues or people in upper management, or when I'm giving a workshop, is using NB strip out. And this tool allows you to remove all of the outputs, make sure that it is coherent, and that you can actually what you're checking into GitHub can be more parsable and more readable on GitHub and GitHub Devs. So I really encourage you to check it out. And also, there's not much we can do sometimes when it comes to diffing and merging. But there is this amazing tool called MBDime. And if you're doing diffing and merging of notebooks locally, you can use it. I'm going to try an attempt here. So for example, if I had this original dashboard that I had, that I showed you before, I'm just going to delete this and run it. And you'll see this little button that is the extension, the MBDime extension. So if I click here, it displays the cells that have been changed. So it tells you this metadata changed because I changed the order of execution. The outputs weren't changed because I didn't run the cell again. But then on the cell that I actually changed, it tells you what it was changed. Okay. So this is very, very nice. It tells you what has been changing. And this one, it didn't do it. And this is very, very powerful because you can then start doing more things with your notebooks. And do you remember that before in a couple of slides, I showed you a very big base 64 hash for a plot. In this one, you can actually go and have, well, now I'm going to change the color of my line from blue to purple or from blue to pink. And you can see in the HTML render version that change instead of that horrible base 64 hash. And it makes your life easier. And notebooks can be used in production. Netflix showed an example probably 9, 10, I'm going to say around a year ago, on how they're actually using notebooks in production. And the way they're doing this is by, again, enforcing these good practices and standardizing the tools that are using, standardizing the workflow. And this comes a lot to choosing the right tool. They didn't reinvent anything in the wheel, or they didn't reinvent the wheel, but they use things like Papermill, that is, again, an Interact community-based product, and use them with other tools that made those workflow robust. If you do it that way, it's completely possible to use the notebooks in production. And also, we have to challenge our assumptions of the notebooks don't scale. There is this amazing project called Pangeo, and they have their own binder hub, but not only they serve dynamic code or readily usable code, but also they give their users access to distributed computing facilities or tools like Dask and Kubernetes. And it scales, and it works, and they can have an instance with over 100 users connected at a time requesting cloud or high-performance computing resources. So it works. Again, you have to think about your whole workflow and the tools that are going to help you to build that pipeline. And how do you find out about all of this? Who do you go to when you encounter all of these problems? Or when you have the urge of saying, I'm going to create something that allows me to embed a notebook inside another notebook, inside another notebook. There is a very nice discourse channel where community users, maintainers, developers, members of the steering committee are there to drive more conversations around the whole Jupyter ecosystem, where you can go and ask questions like that one. Binder Hub installs gives 400 error, and that could be anything, right? But there are people that probably will have seen this before. It's like a Stack Overflow with you the opportunity to also drive the development of the Jupyter ecosystem. There is also this amazing newsletter put together by Tania, where he collates the new packages or new demos or new things around the Jupyter ecosystem, I think every week or bi-weekly, and he sends them the newsletter. So if you want to keep up to date with what is the new hot thing in the Jupyter ecosystem, you go and register there. And also, if you love the notebooks and you're trying to create something new, or you just love the notebooks and have some spare time and some capacity to do it, consider contributing back. It's a very small group of people maintaining the notebooks, and we can help in many, many ways, not just creating code, but using the tools, reporting bugs, helping with design, helping with the community, or just sometimes saying thank you to those that are developing the tools goes a very long way. So if you want to check out any of the packages that I mentioned in these slides, I added all the links. Again, all the slides are going to be available in PDF format, so you can download them and click on the links. And thank you very much. There's again the URL. And you can contact me on the Twitter check or send me an email. And I'm going to be around until Sunday. So if anyone wants to talk about notebooks on the cloud, notebooks, data, please come and say hi. Thank you.